So we were discussing about dielectrics. Dielectrics are insulating materials that cannot conduct electricity but can transmit electric effects. So if you take an atom or molecule of a dielectric, there are two centers of charge. One is positive center of charge, which is the center of mass of all positive charges, especially protons in the nucleus. And second, negative center of charge, which is the center of mass of all negative charges, the atom or molecule, especially by electrons. So you can see the classification of dielectric, non-polar dielectric and polar dielectric. In the atom or molecule or non-polar dielectric, the positive center of charge and negative center of charge are at the same point, coincide. So the two centers of charge coincide at a point. So therefore, P dipole moment, when you write the equation Q into 2A, that is Q into 0. Distance of separation any. Dipole moment is 0. They have no dipole moment of their own. That is non-polar dielectric. Okay? And this is especially because of the symmetric structure. And what are polar dielectrics? Polar dielectric means, so because of maybe their asymmetric structure, the positive center of charge and negative center of charge are separated by some distance, 2a. Therefore, they possess a dipole moment of their own. So their dipole moment is not 0. So they are called polar dielectrics. So two types of dielectrics, non-polar dielectric and polar dielectrics. Non-polar dielectric means there is no dipole moment of their own. This is very important for us because the two centers of charge coincide at the same point. So therefore no dipole moment. Second one, that is positive center of charge and negative center of charge coincide, not coinciding, separated by some distance. So they possess a dipole moment of their own. Okay. Now what is going to happen? When you are going to place a non-polar molecule or atom in an external electric field, what will be its behavior? That you are seeing. So non-polar dielectric, you are taking a molecule, non-polar dielectric molecule, here electric field, outside electric field 0. So when you take a non-polar molecule and positive and negative center of charge coincide at the same point, no dipole moment of their own when there is no external electric field. But when you are applying an external electric field supply, say positive charge be a negative charge be a, they experience a force in an external electric field. Suppose the external electric field for right side. So positive potential is there, negative potential is there, electric field. So positive charge will be experiencing a force in the direction of electric field. Positive charge will move toward right side, and negative charge will experience a force opposite the direction of electric field. Therefore, there may be a slight change in the shape of the molecule as positive charge will be pushed toward right side, and negative center charge will be pushed toward left side. They experience a force. So they are forced to separate by the electricity. When somebody is there from outside, the effect is there. So positive charge and negative charge are forced to separate. They are separated by a distance. When they are separated by a distance, they produce a dipole moment. So this is called polarized dipole moment. Somebody is inducing dipole moment. Induced or we call them polarized. That means a non-polar dielectric becomes a polar dielectric in an external electric field. That is the question here. Okay? A non-polar dielectric becomes a polar dielectric in an external field. This is called dielectric polarization. What do we call the term? Dielectric polarization. When a non-polar dielectric is placed in external electric field, the positive center of charge and negative centers are separated because of the electric field force and produces a dipole moment, which is called induced or polarized dipole moment. This is for a simple atom or molecule. Suppose we are taking a dielectric slab, an insulating slabs, for example, rubber, mica sheet, etc. We are going to place an external electric field. What will happen? So that is the next one. Okay. A non-polar dielectric slab. Non-polar dielectric slab, we are introducing in between an electric field, and this is important one. It's not a single so non-polar dielectric slab in an external electric field. So external electric field can be produced by two positive play, one positive play, another negative. So throughout there is a uniform electric field, that is V naught you can produce. In this uniform electric field, we are going to place a non-polar dielectric slab. So you can take this as a non-polar dielectric slab. NPD slab that I marked as A, B, C, D. All the atoms or molecules are polarized just like we are marking. Initially they are positive and negative centers of charge are at the same point. After applying the electric field, they are forced to separate. So here also, all the atoms so inside electric field, I am just going to remove. Okay, there is already electric field existing inside. Electric field is there inside. All the molecules here, they are polarized. All the molecules are polarized like this. Under the electric field, all the molecules are polarized. And positive will be toward right side, the direction, or positive charge will be toward right side. And negative will be here on left side. Positive charge, positive, negative, positive, negative, positive, negative, positive, negative, like this. So positive, negative, positive, negative, and positive, negative, and positive, negative. So on extreme right side, I am making a dotted line leaving the positive charge on right side and dotted line here leaving negative charge on left side. On the side AB, you can see a collection of negative charge, and on the side C, you can find a collection of positive. In the interior, plus minus cancel. Inside this dotted line, volume charge is 0. And the dipole, that means non-polar dielectric slab, has induced positive charges on positive, that means CD side, and induced negative charge on the side AB. They are called uncancelled induced charges. And in the interior, if you take the total volume charge density, that is algebraic sum, that is equal. So when a non-polar dielectric slab is placed in an external electric field, all the atoms or molecules are polarized. Positive will be toward right side, all atoms are polarized. When you take the interior of volume charge density, that will be 0, plus minus, cancel. But when you see on extreme right, positive charge is alone, nobody is there to cancel. And extreme left side, negative charge is there, nobody to cancel. So there will be uncancelled positive and negative charges on the surfaces. So next diagram is like this. So here you have positive charge concentration, they are uncancelled. Here you have negative charges. This is because of polarization of dielectric molecules. So this charges we call it as induced charges or induced surface density. Plus sigma and minus sigma. I we are using induced charges, induced surface charge density. Once you have positive charge here, negative charge, this produces one more electric field which is inside that dielectric, and this electric field we call it as polarized electric field. And this is in addition to the electric field inside, that is outside electric field. So inside the dielectric slab, two electric fields are there. One is outside electric field, and second one is polarized electric field. So, and the value of E is far less than E naught. So there will be net electric fields inside the non-polar slab, that is E equal to E naught minus EP, and this electric field is known as a reduced electric field. Electric field is known as reduced electric field. E equal to E naught is equal to E naught minus EP. So you have to remember the point inside the dielectric slab when it is placed in external field. There are two electric fields. One is outside electric field and one more electric field which is produced by induced charges on the surfaces, and both are opposite. And EP value will be less than E naught. So net electric field there in opposite direction, E naught minus EP here, and this value we call it as reduced electric field. Reduced electric field. Okay, now it is 8:25. Other points will continue in the next class. Thank you.